Okay, so we've got this model here, okay, and we're given certain situations when t is 2, n is 100, when t is 12, n is 160. And in part A, it says, interpret the constant a in the context of the question. Now, this doesn't mean involving these values here, okay? It's only worth 1 mark, and you need to sort of relate a, as it says, to the context, okay? So when they say the context, in terms of what this model is referring to, so we're looking at the population of a small island, so it's got to be in context, okay? It's got to refer to the population of this island in some way. And it's quite simple to do in terms of working out a is, and always, in fact, the value here in front of the e, okay? Because when we set t to equal 0, okay, the e will become 1, won't it? Okay, and then you're just left with a. So we could say, look, when t is equal to 0, this will always happen, n will equal to a e to the power 0, yeah? Okay, I know there's a k there, but if t is 0, that'll be 0 times k, which is 0, and we know anything to the power 0 is 1, okay? So this will equal a. Now let's look at this in context, because that's what they want. In other words, when t is 0, at the start, yeah, initially, when this model sort of kicks in, at the start, n, which represents the population, will be a, okay? So you could say initially, the population is equal to a, right? So a is the initial population, essentially, right? Part B then, it says show that k is 0.047 correct to 3 decimal places. This is where we're going to use these conditions here. So what I'm going to do now is I'm going to chuck them in, right? So t is 2, n is 100. So if n is 100, put that in. And t is 2, yeah? So I'll have k2, but you can write that as 2k, yeah? We can put the number first. Also, when t is 12, n is 160. So 160 equals a e to the t is 12, so there'll be k12 or 12k. Okay, so we've got now two equations here, okay, with just different values in, same setup, different values. So what we can do now is use simultaneous equations to actually work out k in this case, yeah, which is what they're looking for. Now, in order to do this, what I would do is I divide, okay. So I'm going to write this one down first. You'll find it easier to write this one down first. So 160 equals to a e to the power 12k. And then underneath then, 100 equals to a e to the 2k. Okay, so if I call this, say, equation 1 and that equation 2, all I'm doing is saying 2 divided by 1. Okay, and when you divide equations, you've simply got to divide both sides by each other, right, and be consistent. So 2 divided by 1. Now the reason why I've done 2 divided by that is because look at the power here. You put the highest power on the top, right? You'll see why now in a minute. So when I divide this by this, right, on your calculator, you'll get 1.6 or 8 over 5, right? It doesn't matter what you put it as. The a's here will cancel, won't they? Okay, a divided by a is 1. And with the powers there of e, it's just rules of indices, remember? If you take the powers away, yeah? So it'll be 12 power 12k, take away 2k. So you get 8/5 equals e to the power 10k. Alright? And then to work out what the power is here, remember you create a logarithm, yeah? So you sort of swing the base, if you like. Okay, because you've got the power here. This is the base, so swing the base and create a logarithm. However, when you swing the base, of course, the base is e, isn't it? So it's logarithm to the base e, which is just ln. Yeah, log to the base e is just ln. Okay, it's a special logarithm, it's the natural logarithm, and you're left with the power there, 10k. What I like to do, right, I just like to think, take the e over the other side. That's what I think. Take the e over the other side, and it becomes ln. Okay, just keep it simple like that. Take the e over, and it becomes ln. The opposite of e is ln, because when we take things over the other side, we always do the opposite, don't we? Okay, you know, if I was squaring this side, if I had x squared equals something, Okay, when I take it over, I'd be square rooting, when I put plus or minus as well, but you get the idea. You do the opposite. So take the e over uln, and then of course to get k, you just got to divide by 10. Okay, so 8/5 divided by 10 now will equal to k. So I'll get my calculator. Ln 8 over 5. Okay, and then divide that by 10, and it comes out to be 0.047, exactly as required, right? The 3 decimal places. Now, what you need to do then is work out a as well. It doesn't ask you in the question to work out a, but you're going to need to in order to help you with c, right? So we'll work out what a is, and that's quite simple because you just sub it into, say, equation 1, yeah? So we just say, look, sub into 1. So you have 100 equals to a, e to the 2k, like that, yeah? And then, 100 equals a, well, 2k, well, that would be 0.094, so I worked that out there. All you've got to do then is take the e over the other side, yeah? Because this is a times this. So to get a, then you just divide like that there. Okay, so I've got 100 divided by e to the power 0.094, and that comes out to be 91.02. We'll put a few decimal places there. So it says then, find the population and see when t is 20. Well, remember, what you need to do now is write the model as it is. So n equals to 91.02. Okay, that's what a is, yeah? 91.02 e to the power kt. Okay, so you worked out a to be 91.02. You worked out k to be 0.047. So then when t is 20, n is 91.02 e to the power 0.047 times 20. So I'll do all that in one go. 91.02 e to the power 0.047 20, and that equals to 233. Now it's 0.00 whatever, which is Brill, okay? Remember, it's got to be in context, okay? So you've got to put it as a whole number because we're talking about population. You can't have a decimal point in your last answer. Population means it's got to be a whole amount, yeah? That rounds really nicely there.